Good day, class. Let's go ahead and go over this last semester, well, not semester exam, but last test we're going to have for the semester, and we're going to be dealing with sequences and series. Now, it says in this first problem, find the first four terms of the given sequence, then determine if the sequence is arithmetic, geometric, or neither. So what we're going to do first is do the first part of it, give the first four terms of the sequence. So we're going to be focusing on this part right here, because that's the first thing we're going to do. So from here, we're going to go ahead and bring out the first four terms. So this is a pretty easy task. All we do is state n equal to 1 and then write down the appropriate notation. So this is 5, n equal to 2, the substitution. The next one in the sequence, so this is 7, n equal to 3. So this is going to be 2 times 3 is 6 plus is 9. And n equal 4. 2 times 4 plus 3 gives you 11. So if I go ahead and then do this next part, because see the next part after this, now we did the first four terms, so we have this sequential set of numbers. My next part that what I'm going to do is now do this next part, determine if the sequence is arithmetic, geometric, or neither. So that's the second part of it. Now, one of the things we have to do is we have to find out if there's a common difference between these values. So like here, between here and here, there was a plus 2, plus 2, plus 2. Well, we're going to find out that this one has a constant difference of addition. And because of that, because it's an addition and that's a constant difference, means that this is arithmetic. That's how you tell if it's arithmetic, because you will either have a constant difference, in this case addition or subtraction, and if not, you have normally something that's geometric. If you have a constant ratio, that means that from one to the other, you always could find a certain number, either being multiplied or divided. So let's go ahead and do the next one. Now with this next one, we're going to do the same thing. N equal to 1, 1 cubed plus 1 means I have 2. N equal to 2, 2 cubed plus 1 means I have 8, I have 9. N equal to 3, 3 cubed plus 1, 27 plus 1, which is 28. And then from here, we're going to have n equal to 4. That means we have 4 cubed, not 4 cubed. Actually, no, that we do have 4 cubed plus 1. Now for this 4 cubed, that should be 16 times 16. I kind of want to say that that's going to be 256, but I'd rather use my calculator instead of guessing, because I don't want to take a guess for that. I want to make sure I know exactly what the right answer is. So let me go ahead and just pull up my calculator and verify. So I'll actually come up with the solution. 4 cubed. Oh no, it's actually 64. It gives you an idea of how far off I was. I wasn't thinking in the right manner. I was actually thinking 4 times to the 4th power. So with this, I have 64, which means I have 65 with the addition of 1. So I have 65. So let's go ahead and look to see what is actually occurring in this one. In this one, we are going ahead and finding that this one has a difference of 7. But then from there, we have a difference of 21. So there's really not, this is not arithmetic for sure. I found the first 4 terms. It's going to be something different. Actually, this one right here, because this one does not have, well, it may have a constant ratio. Let's find out. Let's do 9 divided by 2. Oh, hold on a second. Let me clear that out. Okay, 9 divided by 2, 4.5. 28 divided by 9. And really what I'm trying to do is see if it's geometric. Okay, so this one's not geometric either. So this one is neither. And the reason why it's neither, and actually let me bring up one example. You could take any 2 terms in any kind of sequence you have, any 2 terms as long as they're consecutive. So like in this case, you see how I did 9 and 2 and 28 and 9. I could do 65 also by 28. And you must get, if you don't get constant R constant value. See how it's changing? That means you do not have a geometric, or you do not have arithmetic. So for this one is neither. Neither, because no constant addition or subtraction exists, and no constant ratio exists. So for those two reasons, it's a no. That means it's neither. For either one. Okay, let's go ahead and do the next one and see what we come up here. So let's do the first four terms on this one. So we're going to do n equal to 1. So 2 times 3 times 1, which means I have 6. N equal to 2. 2 times 3 squared, which means 9, which means I have 18. N equal to 3, which means I have 2 times 3 times 3, which means I have 27 times, it should be 27, yeah, 9 times, okay, so 27 times 2, which is 54, and n equal to 4, which means I have 2 times 3 times the 4th power in this case. So let's go ahead and just pull up my calculator real quick and get that one. 2 times 3 raised to the 4th power. 162. So I have 162 in this case. So 162. So let's go ahead and see if this one, there's a common ratio. I would imagine that this one's geometric because it's the only one we haven't yet done. But let's verify. We don't want to guess. It may be either as far as we know. But the first two terms was 18 divided by 6, which is 3. So let's go ahead and figure out 54 divided by 18, 3. And 162 divided by 54, 3. Which means that in this case, you see how we have a constant ratio? This one is geometric. It's geometric, and it's geometric because the constant ratio exists, which in this case r is equal to 3, which means that each one of these is being multiplied by 3 to produce the next one. Now let's go ahead, and now with that in mind, we're going to be now given a sequence, and we're going to be asked to find the rule or the pattern. So let's go ahead and do that. Find the rule or the pattern for each sequence. Now the first thing we're going to do is with each one of these sequences, we're going to follow a 3-step pattern. Step 1 is to find a 1. So like for this one, it's 1. Step 2 is to determine if the sequence actually contains a D or an R to see if it's geometric or arithmetic. Now with this one, that's plus 3, plus 3, plus 3. Safe to say that with this one has a D value, which means it's arithmetic at D equal 3. So with that in mind, we're just going to go ahead and apply our equation. Step 3 is to apply the equation in regards to this specific, it's an arithmetic series equation, a sub n, which is also found in the white sheet that I gave you. It has like the 4 cards. That one you're going to be able to use on the exam, but in this case, the actual equation is a sub 1 plus n minus 1 times d. And from here is just a substitution. So what we're going to do from here is a sub 1, 1 plus, actually, you know what I'll do? To make this better for you, let me do the substitutions in red. And in our case, our d is 3. Which means, and the only thing I need to do now is just simplify. So with this one, a sub n is 1 plus 3n minus 3, which means that the rule or the pattern for this sequence is actually 3n minus 2. And if you're ever in doubt, just try it out. Go ahead and submit 1 in there, I get 1. If I put 2 in there, I'll get 4. But if you're ever in doubt, if you have something right, go ahead and take this and check it. You have the ability to do that. And I did just mentally. Now let's go ahead and look at this one. Now with this one, same thing, 3 steps. Step 1, a sub 1 is equal to 8. And then from there, I'm going to go ahead and see if I can determine step 2, which is either trying to find an R or D. Now with this one, there is really, goes from 4 to 2 to 1. So that means this one is definitely not arithmetic because there's really no constant difference. But we're going to now check to see if it's geometric. And to check to see if it's geometric, we're going to go ahead and do the equation, which means that R is really a sub n plus 1 over a sub n. And this is similar to what I was doing right above when I was checking to see if it was geometric. You take the next term in the sequence and divide it with the previous. So for example, you could take any 2 terms in the sequence. Like I'm going to go ahead and take 4 divided by 8. And I'll find 0.5, which is a half. If you take 2 divided by 4, same thing. I'll give you 0.5. So you can take any 2 terms and determine, in this case, R is a half. And if I did it by hand, so R will equal 1/2. If you did it by hand, any 2 terms, 4 over 8. Reason being, if you call this a sub n, this is a sub n plus 1, the next term in the sequence. So that's the reason why you see this configuration. And where the 4 goes here and the 8 goes here. So from there, that's how you determine you have a half. Now step 3. Step 3, this equation is slightly different. The equation for geometric is a sub n is equal to a times r n minus 1. So that means that in this case, if we have this, then all we have to do is just a substitution values again. A sub n is equal to a sub 1, which is in this case, here I'll do it with color A. And then the other one, the R, actually I did R in red, so I'll continue red. And you have n minus 1. So in this case, that's your equation. And if you ever in doubt, again, you could check it. You could go ahead and put in 1, and you'll find out that this is 0, and that comes out being 8. Because this becomes, well, let me go ahead and go through 1. And sub 1, if you want to check to see if it's right, 1/2 times 1 minus 1, 8 1/2, 0, which equals 8, because this is really 8 times 1, which is 8. So you get the same thing back. And if you want to try it for 2, go ahead and try it for 2. It should produce, it will produce the same sequence because you have something that's correct. If it's correct, you will get the same thing back. Let's go ahead and move on, and let's talk about summation notation. Now, summation notation was interesting because it exposed us to something new. And really what exposed us was a couple of things. First of all, they want us to write the expansion and then find the sum. Now, for those that need a refresher on what the summation notation means, this refers to the starting point. This refers to the ending point. Why? Because this sequence is infinite. So we need to tell it where to start and where to end. And lastly, this is just the equation that's going to be applied for those 5 terms. Which means that if I start using my application of the equation, I'll end up with this. I'm going to go ahead and take 1. I'm going to start with 1 squared because remember, see how it says k equals 1 plus 12. I'm going to put these in brackets because I'm going to be adding them together. So for like the next one, I'm going to go ahead and do 2 squared plus 12. The next term in the sequence, 3 squared plus 12. Adding 4 squared plus 12. And lastly, 5 squared plus 12. So that means in this case, I'll get 13 here plus 16 plus, that's 9, plus 12, which is 21, plus 16, which is 28, plus 25, which comes out being 42. And everything, no, 37. So let's go ahead and add all that together. And I'm kind of blocking my view a bit. I think the first, ooh, I'm also writing on this thing. Let me do this, go back to there, and let's go bring this back up. So that means that I have 13 plus 16. So 13 plus 16 plus 21 plus 28 plus 37. Which means that I have 115. So write the expansion and find the sum. So my sum of this is equal to 115. Which means that this is the answer. So the summation of this, 115. That's what it comes out into 2. Now we're going to do the same thing with question 7. Now I am running a little bit short time, so I'm going to skip question 7, but you're going to do the exact same thing as what we did on top. Expand and do the same thing. Well, let's go ahead and actually move into one of these right here. Express each sum using summation notation. Now, the nice thing about this is that I kind of explained what the components of the other one was. And if you're going to express the sum in summation notation, a couple of things we need to define. We need to define where do we start. We also need to define the actual sequence. So if you look at this sequence, this is n equal to 1, n equal to 2. You know what, if you want, let me try. I was going to try to make this smaller, but this is n equal to 3, n equal to 4, and this is n equal to 5. Which means I have 5 up here. Which means that no matter what I do, I'm going to go up to only the 5th term. We're going to express that summation. The other thing I need to express is that I'm going to be starting at the first term, n equal to 1. Now the last thing that I don't have that I do need to generate is the actual sequence, like the actual equation for the pattern of this sequence. So what I'm going to do is use the 3 steps. Step 1, a sub 1 is equal to 5. Step 2, find a constant difference d. So like in this case, this is plus 4, plus 4, plus 4, plus 4, so it's 4. Step 3, our equation generation, a sub 1 is equal to a1 plus n minus 1 d, and then apply the substitution. So we have 5 plus n minus 1 times 4, which means I have 5 plus 4n minus 4. All I did is distribute to achieve this answer, and then from here this is going to simplify to 4n plus 1. So when we write this in here, since we're not talking about n's anymore, for a sub n's, we're actually talking about k's. This is going to be 4k plus 1. And this is your answer. This is the summation of that, the notation written in summation notation. Talk about the starting point, k equal to 1. We have all 3 elements of it. Starting, ending, and equation defined right here. So we have all 3, and this is what it took. If you don't know how to do it off scene, then you got to do everything I wrote down here. So now let's go ahead and find the given term in the arithmetic sequence. So they want me to find the 20th term. Now with that, I got to do something similar like I did here, where I got to find the pattern or the rule first, and then apply it exactly here. I made that green. That's where I got to do. So in this case, let's go ahead and start by doing our 3 steps. Step 1, a sub 1 is equal to 15. Step 2, find the constant difference d. So in this case, we go from 6, 6, so we get 6, and then from there, step 3, use our equation to find the actual pattern. So from here, it's going to equal then substitution 15 plus n minus 1 times 6. And let's go ahead and actually use this to find out. Now, one thing that I'm remembering as I'm going through this is that please take the time to try each of these out. I know I've done several of them. I'm on question 9. But you have to be able to try this out before you actually look at what I'm doing. And the reason why this is so important is because there is a certain mechanism in your brain that with recall, if you try it and don't know and then look at it and then try it again, it's going to be, what I'm going to want you to do after you're done with this video is go ahead and try this actually quite a few times. And the reason being, hold on. And I just wanted to go ahead and finish off saying that when you work on this, please make sure to take the time to rework it again on a separate piece of paper. Make sure you're able to recreate the magic. But let's go ahead and continue with question 9. With question 9, and we're going to find that I was going to finish doing this equation right here. So let me go ahead and get that going for a second, because this is going to equal then. Is moving just a bit slower than anticipated. If you want, let me pause. Okay, fantastic. Hopefully this is all fixed and this thing will be writing as it should. So, still is not. Oh, there it is. Okay, great. So let's go ahead and actually, the general equation on this then would be 6n plus 9. And from here, they want us to find the 20th term. So what I'm going to do is this. A to the 20th is equal to 6 times 20 plus 9. That's a 20. So that's going to be equal to actually 129. And that is the answer for this one. All right, now let's go ahead and move on to question 10. Question says find A of 15. Now with this one, you're actually given a lot of information. Step 1, A1 is 7. Step 2, D is equal to -3. We're going to use this equation. A sub n is equal to A1 plus n minus 1 times -3. And that's going to give me, after I distribute this, -3 plus 3, which means I have -3n plus 10. And the only thing I'm wanting to find out now is A15. So in this case, we're going to go ahead and do -3 times 15 plus 10, which means I get -45 plus 10, which equates to, the solution for this one is going to be -35. So there you go. So that's how you do this. Now let's go ahead and move on to the next question. They want us to find the sum of the first 50 terms. Now for this one, we need to write down the equation for the sum of, well, either we have to find out, is this arithmetic? And I think it did. I think the last page it says it was an arithmetic series. The reason why that's important is it tells you which equation to use. So it does say it on here, arithmetic series. So if that is said, that means that when we work over here, we're going to go ahead and find the sum of the first 50 terms, which means that we can use this equation. S of n is equal to n divided by 2, a1 plus a n. Now in this case, I know a couple of things already. Automatically, I could go ahead and say I have 50 divided by 2. A sub 1's been given, 5, but I do not know what A sub n is. So I'm going to have to go ahead and use my 3 steps to get that answer. So A sub 1 is equal to 5. 2, the difference between these is a constant 5, which means that D is 5, and it gives me the ability and the benefit to discover what my sequence equation is going to be. 5 plus n minus 1 times 5. Once I distribute this, I'll get A sub n is 5 plus 5n minus 5, which means A sub n is actually equal to 5n. So if that's the case, and I want to know what the 50th term of this is, A sub 50 is really equal to 5 times 50, which means it's 250. which means that this unknown is really 250. And plugging it all in the calculator, let me get this out, and then that back on. Means I really have 50 divided by 2, and 5 plus 250, which means I have 6,375. Which means I have let me go ahead and start writing it. 6,375 as an answer. That's what the summation is of the first 50 terms. Now let's go ahead and do this next one. Now this next one is actually done a little easier because we actually know that if this is arithmetic, then we still have this equation S of n is equal to n divided by 2, a sub 1 plus a sub n. This one, all the information has been given to us. First of all, our n is this value right here. So 10 divided by 2. A sub 1's been given, n as well as a sub n. So like in this case, we're going to get, let me bring this up, bring that, and do the calculation for this. So like in this, let's go ahead and compute this and come up with an answer. The answer, 10 divided by 2, which is 5, 3 plus 41, which is 44, gives me 220. So over here, corresponding solution, 220 for question number 12. Let's go ahead and now find the answer for question 13. Now this one we're going to move to geometric. Geometric has a slightly different equation in order to find the summation. Actually, find the given term. Actually, no, they want you to find the given term, so not the summation. Actually, we're going to find the given term. And for this, we will be using a set of equations. The set of equations we're going to be using is, first of all, we still need to come up with A1 and R, which is been given right here. But we're going to actually apply this equation that is A sub n is actually equal to A R n minus 1. So let's go ahead and apply that. Now our A is 3, our R is 2, and we have n minus 1, so there's my equation. Now I'm going to try to find this out for A sub 12. So A sub 12 is 3 times 2 times 12 minus 1, which means that this is really 3 times 2 times 11. Which means that I have, to get the solution, let me go ahead and apply that numerical computation to see what it comes out being. So here you go. Let's do that. 3 times 2 raised to the power 11 means that this one, the computation for the answer for this one is 6,144. That's what the A sub 12 term is going to be on this one. Now this one asks you to find the 10th term. Now this one we have to find A sub 1, but that's easy. Step 1 is going to be 1. Step 2, we're going to find R. R, if you cannot see it, it's going to be the previous term divided by the next term divided by the previous term. So this is A sub n plus 1. This is really A sub n plus 1 divided by A sub n. So you could take any two terms and do that. But the resulting answer is a half. So I have a half here. So that means step 3, I'm going to go ahead and find the 10th term of this computation. That's 1 times 1/2 times 10 minus 1. So for this, let's see what that answer comes out being. 1 times 1 divided by 2 raised to the power 11. I'm sorry, not raised to the power 11. 10 minus 1, which will be 9, raised to the power 9. And our answer, well, let's see what that's going to be in a fraction. If I math frac that, it's 1 over 512. So that's what the 12th term of this will look like. Now with this one, they want us to find the finite sum of this geometric series. Now for that, we have to use this equation, which is S of n is equal to a 1 minus Rn divided by 1 minus r. From here, this becomes just a simple act of substitution. 8, 1 minus r, which in this case we know it's a half. And they want me to find s of 8, so I'm going to go ahead and write 8 up here already. And that comes from here. It's the 8 term, that's the n. This means that n is equal to 8. So from here, let's finish the rest. I'll have 1 minus r, which is again a half. So if you notice, I did the substitutions in red and purple. And from here, all you need to do then to find out the finite sum is to actually just calculate it. So calculated, let's go ahead and calculate this. I move this because I have that there. Clear this, I'm going to have 8. I'll put double parentheses in this case. 1 minus 1 divided by 2 raised to the power of 8. Close parentheses there, divided by 1 minus 1 half. Hit enter, and there's my answer, 15.9375. Here's my solution, my answer. This is an easy benefit to me. Now for this one, on find the finite series for this one, we still use the same equation, but we need to find, step 1, a sub 1 is equal to 1. Step 2, find r. R in this case is going to be 1/3. The reason why I know is that because take any two terms, if I take 1 divided by 9 and divided by 1 divided by 1/3, I just take these two right here. Take the previous and divide it with the next one divided with the previous one. This comes out being 3/9, which means it's 1/3. And you could do the same thing by doing 1/3 plus 1. But in our purposes, we're going to have to find the s term, so we're going to do the same thing here. Let's go ahead and do the substitutions. 1 minus r, which is in this case a third. And we want to now find s of 10, so this is 10. We're going to divide this by 1 minus 1/3. And from here, let's go ahead and actually get the answer computation. So let's clear that. I'm not going to put the 1 because in this case, it's not necessary. 1 times whatever the number is the same number back. 1 divided by 3 raised to the power of 10. Oops. I don't want to end the parentheses there. I want to end it here. Okay, good. I'll finish this up during my conference. So, okay, great. Let's go ahead and continue with this video. And lastly, the last part we left off is we're going to go ahead and actually figure out the summation of this composition right here. So let's go ahead and actually get the value for that, and we'll be able to see if so I'll put down the solution. Bring this up, and I was actually in the middle of typing in when I did this. So let's see, let's do 1 minus 1 divided by 3, and there you go, and let's see what we get. Okay, we get 1.499. So in this case we get, hold on, let's take this away from highlighter and do what I just did, and do, answer is 1.499. Not sure if it rounds, actually it does round. 1.4997. So there you go. That's the actual answer for question 16. Now the next one, I think the directions here is find the sum of the infinite geometric series. Anytime you see directions of like that, this says find the sum of the infinite geometric series, which are these directions right here. It's asking you to find out if it converges or it diverges. Now, if it's asking for a sum, then I think it's assuming that it's going to converge. So the only thing you need to do is find out what the R value is of the convergence. Remember, convergence is determined with a series if the R value is less than 1. If the R value is less than 1, then we have a convergence. And we're able to use this equation, which in simple terms means that we have a divided by 1 over r to go ahead and actually find out what value converges at, what the sum is in essence. Now, the r value on this one is going to be 1/3. And for those that have difficulty seeing it, you could take one term and divide it with the next one. So, okay, so let's go ahead and continue solving this. So r equal to 3. Now our a value is going to be our first value, which is this 3. So we're going to put 3 is equal to 1 minus 1/3. That 1/3 does not look very appealing to me. So let's go ahead and redo that. 1 minus 1/3. So from here, let's see what this value converges to. So we're going to bring out a calculator. And so we got 3 divided by parentheses 1 minus 1 divided by 3. Comes out being 4.5. So in this case, we'll get 4.5 as an answer. Okay, let's go ahead and now do question number 18, how to do the binomial theorem. Now the binomial theorem states that we're going to go ahead. Now when you do the binomial theorem, you want to start with leaving r and choose r's blank. And we're going to go ahead and remember that this is called a, so a is equal to x. This is called b, so b is equal to -3. And let me move this down a bit to kind of clear space, but what I'm going to try to achieve here is you leave the parentheses blank. We're going to fill those in later, but we're going to apply the binomial theorem that states that you start with x to the 5th, and the b value, your -3, is going to be 0. And then you're going to add the next one, again leaving parentheses blank, but then the next term, your x is going to go down by a degree, while your b value is going to go up by a degree. So if you notice, going up, one is going down, the other one's going up. Continuing this pattern, we're going to get x cubed times -3 squared, and we're adding this. So from here, this is going to continue now be x, ooh, hold on, that's not supposed to go there, like this. This really should be x squared times -3 cubed plus, after this, we're going to get x to the first power times -3 to the 4th power plus the next parentheses, and lastly we're going to finally end up with x to the 0. I didn't like how that came out either. Hold on, let's fix that. X to the 0 times -3 to the 5th. Now the parentheses normally are going to have the n choose r portions, and you could still do that. You can still figure out by the calculator. But this one says use Pascal's triangle. So what I'm going to do is use Pascal's triangle to figure this out. Now this is a degree term 4th. So if I was going to achieve Pascal's triangle on here, let me do it a little bit over here to the right so y'all can see how Pascal's triangle is going to be. I have 1, 1, 2, 1, 1, 3, 3, 1, and what I'm doing is just adding. Once you start with this basic little triangle on top, all you do is adding 1, 4, 6, 4, and 1. This is n to the 4th, so this is what really I'm going to focus on. So which means that each of this is really 1, this is 4, that's going to be 6, that's going to be 4, that's going to be, hold on, 1, 4, oh, okay, let me undo this. Actually, the reason why that one doesn't work is because I mistakenly said that that was n to the 4th. We are not doing n to the 4th, we're doing n to the 5th. So we're actually supposed to continue to do one more row. 1, 5, and 10, 10, 5, 1. So this is n to the 5. This is really what I'm going to be using. So in this case, I'll have 1, 5, 10, 10, 5, 1. Okay, now Pascal's triangle just helped me in just achieving this a little bit faster. Now, one thing that I keep in mind, anything raised to the power of 0, like this one, will cancel because it becomes 1, and the same thing with this one. That's going to cancel and become 1. So when I write this in expanded form, this is just x to the 5th plus, now this is going to be negative 3 times 5. So we're going to put negative 15 x to the 4th plus, in this case, negative 9 times 10, which is negative 90 x cubed. And then from here, this is going to be negative 27 times 10, which is negative 270 x squared. And then this is going to be negative 3 to the 4th power, which I think is 81, but yeah, it should be 81. But let me go ahead and just double check. I'll rather be correct by double checking. Yeah, negative 81 times 5, which is 405, I believe. Yeah, negative 405. So we have plus negative 405 x, and lastly, negative 3 to the 5th power. So let's go ahead and put negative 3 raised to the 5th power. That comes out being negative 243. So this answer comes out being negative 243. All right, fantastic. Now we're going to do this. You're going to do the same exact steps doing question 19. And I could go ahead and actually do question. If you want, let me go ahead and work through it with y'all. If you think you know it already, then just go ahead and bypass this portion. But this is A. This is B. So A is equal to 2x. B is equal to 3. N is equal to 4. Now again, I'm going to start by doing my parentheses and start by doing 2x, and this is in parentheses 4 times 3 to the 0 power, plus parentheses again 2x cubed times 3 to the 1st power, plus parentheses again 2x squared times 3 squared, plus parentheses again, and I'll get 2x to the 1st times 3 cubed, plus parentheses again, times 2x to the 0 power times 3 to the 4th. Again, this will cancel out to 1, and so will this. So from here, let's use Pascal's triangle. Now, I already have Pascal's triangle set up. So I'm just going to look at n to the 4, which is the one right below it. So I'm going to look at this and say, okay, I got 1, 4, 6, 4, 1, which means that this is 1, 4, 6, 4, and 1. And all I need to do from here is just simplify this. Now, there is something that's going to occur here. This 2 is going to distribute here and here, which means that in this case, once I separate this, this really becomes 2 to the 4th. So 2 to the 4th, it comes out being, let's see, that's going to be 8 times 2, so it's going to be 16 x to the 4th for the first term. The second term, I'm going to have 2 cubed times this one, which is going to be 3 times 4. So that means that I have these three values I'll be multiplying together, which in essence is 8. This comes out being 4 times 8 times 3, which comes out being 32, which comes out being 96. So it's going to be 96 x cubed. This square, again, is going to multiply there, so I'll have this value, 6, times this value, which is 2, oh no, it'll be 2 squared, which is 4, times 9. So I'll have 6 times 4 times 9, comes out being 216. So for this one, I have 216 x squared, and addition over here, this one's going to be 1 and 1, so I'll have 4 times 2 times 27. And the 27 came from this right here. The 3 cubed comes out being 27. So I'll have, let me move this so I could see what's in 4 numbers. Oh, I think it was 4 times 2 times 27. 4 times 2 times 27. Comes out being 4 times 2 times, it comes out being 216 again. So 216, oh, x plus, lastly, just 3 to the 4th. So 3 to the 4th. See what that comes out being. 81. So in this case, I'll have 80, oh, again, 81, and that's it. And that is the expansion portion of that. Now, this very last question that we have actually wants us to find a specific binomial term, the 6th term in the binomial expression. So what I'm going to do, once you want to do that, there is an equation. The equation comes out like this. So you got to know, if anything, you got to know how the equation gets applied. N, j minus 1, a n minus j minus 1 times b j minus 1. So our j value is this. So what I'm going to do is just let me go ahead and just start doing the substitution. My n value, so here, if you want, I can write it up here on the side. J is equal to 6, which is the term. And it comes out being from this right here, which will be 10, which is the exponent of that binomial. A is still the same, 3y. B is still going to be negative 2. So in this case, my n is 10. J minus 1, which is 6 minus 1, times a, n, which is 10 minus 6 minus 1, times b, which is 6 minus 1. Now, I do know what a and b is already, so this, let's go ahead and fill in those numbers, 3y and negative 2. Now, let's go ahead and simplify this some more. This is going to give me, in our case, 10 to the 7th, oops, I'm not right that way, 10 to the 7th, expand this page, 3y, 10 minus 7 times negative 2 7th, which means I have 10 to the 7th, 3y, 3 times negative 2 to the 7th power. Now, I need to find out what 10 choose 7 is. So for that, I'm going to go ahead and pull out my calculator to do that. Now, I'm going to use the, I'm going to write down 10, go to math, PRB, use option 3 and choose R of 7, and I'll find out that that is 120. So that means that right here, this is 120 times, oh, you know, and this needs to be in parentheses. Because when I distribute this, 3 cubed, I'm going to get 3 cubed, and I'm going to move this negative 2 to the 7, and I'm going to put this y, which is the only variable I have, over to the n. Now I'm going to calculate all this right here to get an answer. So I'll get 120 times, let me move this, so I get that right. Okay, good. 3 raised to the 3rd power times, oh, hold on a second. I want to get down here. Times negative 2 raised to the power of 7th. So it comes out being negative 414,720. So the answer on this finally is negative 414,720. Why? And that's the term, that is what it is for the 6th term. Oh, except for one thing. That's cube, because that carries. That's cube there. Okay, great. All right, class. Good luck on tomorrow's tests, and best of luck.